Hey everyone, welcome back. In today's video, we are going to explore a very important concept, transactions. We will cover what are transactions, how to use transactions in a Spring application. We will also cover a Spring Boot application using Hibernate, that is basically Spring Data JPA. And in the end, we will also cover all the important propagation settings related to Spring transactional annotation. So without further ado, let's get started. First of all, let's understand what are transactions. A transaction is a sequence of operations, and all the operations which are part of a particular transaction are considered a single unit of work. And this unit of work is atomic, which means either all the operations will be completed successfully together or they will not execute at all. So if an operation of the transaction, let's say, fails, then the entire transaction will be rolled back. So a transaction should leave the database from one consistent state to another consistent state. Suppose we have a business functionality and it has three operations. So this is operation number one, this is second operation, and this one is third operation. And for this functionality, these three operations are considered a single unit of work. That means we want them to execute together successfully, or we don't want them to execute at all. And if all of them succeed, then we say this particular workflow is complete. Otherwise, we want to roll back, because we don't want to leave the database in an inconsistent state. What if only OP1 and OP2 were completed successfully but OP3 failed? So that will leave the database in an inconsistent state. That's why we want to consider them as a single unit of work, and we want all of them to be completed successfully. All right. Now without transaction, what will happen? Let's say OP1 completed successfully in the database. Similarly, OP2 also completed successfully in the database, but OP3 failed. Since database is in inconsistent state now, because we will see partial changes related to OP1 and OP2 but not for OP3. So we can't say that this particular workflow is completed successfully. But how do we handle the partial updates? How do we handle the updates related to OP1 and OP2? Somehow we'll have to track the changes and we'll have to revert back manually so that we can revert the changes which were done by operation 1 and operation 2. So that is the problem when we don't have the transactions. Now let's say what happens when we use the transaction. Now when we use transaction, what will happen? All the operations will be part of a particular transaction. So this is the transactional boundary. And when we execute the code, the application will make sure that it completes the transaction successfully. So let's say if OP3 fails, the entire transaction will be rolled back. So let's see what happens now. When we execute the transaction, let's say it executed the operation number 1 in the database. Similarly, it will try to execute the operation number 2, which will do something in the database. And in the happy scenario, let's say operation number 3 was also completed successfully. So we can say that this particular transaction is complete successfully, and we can mark this particular workflow also as complete. But let's say what happens when operation number 3 fails. In that case, this is the responsibility of the transaction that it will automatically roll back the changes done by operation number 1 and operation number 2. And so all the changes will be reverted back to some last known state, last known good state of the database, which will leave the database in a consistent state even after the failure of operation number 3. So that's what we mean when we say the transaction is a single unit of work. Of course, it can have multiple operations, multiple independent operations, but they are considered as a single unit of work, and transaction boundary will make sure that they remain a single unit of work. And it makes the rollback easier in case one of the operations fails for whatever reasons. Now, if you notice, here we are executing the operation number 1 against the database. Similarly, here we are executing operation number 2 against the database. Now it could happen that database will have its own transaction management. So within the boundary of this single transaction, here it is, it could happen that at the database level, database is handling different transactions related to different operations. So these transactions are called physical transactions because these transactions are handled by the database itself. But this transaction is called logical transaction, because here we are creating or we are defining the transaction boundary from the application perspective. Even though, let's say, these three operations are different to each other, maybe they are manipulating different tables in the database, but from the workflow perspective, these form a particular workflow and so a logical boundary of a single transaction. So that is the difference between logical and physical transaction. A single logical transaction could have multiple physical transactions. So physical transactions are related to the database because that's where actual thing is happening, and logical transaction is defined on the application level. Now coming back to the topic of this video, we will cover transactional annotation which is provided by the Spring framework, and this transactional annotation helps us to manage the logical transactions. So using @transactional annotation, we can define the logical transactions in our application, and Spring framework will make sure that when we execute a particular transaction using this annotation, it will handle this part. That means either all the operations will be completed as a unit or they will be rolled back, and this will be handled by Spring framework. All right. So now that we understand the basics of transaction, let's move on and understand the propagation settings. In any application, there will be many classes, many components, and different methods, and they call each other. And that's how the application flow works. Out of them, when we have multiple transactional components, transactional methods, and when they call each other, then we need to understand how the transactions will be propagated, how the transactions will be handled by the Spring framework. So let's say when Spring framework sees a transactional method, it knows it has to execute that method in a transaction. But this transactional method is calling another service which is also transactional. So what will the framework do? Will it create the new transaction before calling the transactional service, or will it reuse the same existing transaction in order to call the service? So this is called transaction propagation, and there are different settings that we can use to deal with such conditions and scenarios. And these settings are called propagation settings, transaction propagation settings. And you can see this is basically an enum that we will use when we see the code demo. And there are different possible values like required, requires new, supports, and so on. Required is the default attribute, and just to explain the basics, what it does, let's say when we use the default setting, what it checks when it executes the method, it will check if a current transaction is in progress or not. If there is an existing transaction which is running, it will join the same transaction. Otherwise, it will create a new one. So that is the behavior of required, and in the same way, different propagation settings have different behaviors. So let's move on and see a code demo and see everything in action. We'll set up a new project for this demo. This is going to be Maven in Java, and let's fill in the details. Spring transactions. Like this. And then we'll add the dependencies. For now, we need Spring Data JPA. We also need MySQL driver because I'm going to use MySQL database, and Lombok. We'll keep things simple. I'm not going to expose any web endpoints for this demo, so I haven't included Spring Web dependency. So let's generate the project and open it in IntelliJ. So here we have the downloaded project, and I'm going to open it with IntelliJ. While it opens and configures the project, let me show you my MySQL database. So this is running, and this is the schema or the database that I'm going to use. So make sure you have a database running if you're following along. It has downloaded all the required dependencies, so we can move on with the code setup. The first thing we'll do is we'll provide some required properties, some configurations, because this is going to be a JPA project in which we need the database connectivity. And for the sake of simplicity, I will rename it to YAML. You can use the properties file. It's just my personal preference. All right. So let's provide the details. What do we need? We need to provide the data source. So we have data source. First of all, username, which is root in my case, then password. You need to provide your username and password for the database connection, and then URL. Here we will provide where the database is running because the application will connect to that database. So this is jdpc colon mysql colon / localhost and the name of the database, which is Hibernate demo in my case. Then we'll also provide the JPA related properties, which is show SQL, because we want to see what Hibernate or Spring Data JPA is generating when we run the application. And this one with create. Since we don't have the required tables for this demo, hence we are using this DDL-auto property, which will create the required tables based on the entity that we define. But in the real project, we don't need to use this setting. We will always have the database and the required tables already. We simply need to write the code base. So this is just for the demo. So we have the required properties. Let's add the entity and everything. So we'll add a new entity. In the entity package, let's name it task. We'll keep it simple because we will be focusing on the transaction part. So we will keep the entity simple. And we know how to define the entity. We need to use the entity annotation from the JPA. And we will also use the data annotation from Lombok because we don't need to generate getters and setters. So we want to avoid that. First of all, we will define a primary key, which is going to be an auto-generated value like this. And we'll define one more property, which is, let's say, title. That's all. So this entity will have two columns, one primary key, which is ID, and the second column is going to be title. And in order to work with this entity, we'll also create a repository, which is Spring Data repository. This is going to be an interface, and we can keep it in the DAO or the repository package, doesn't matter. We'll name it task repository, and it will extend JPA repository like this. The first type parameter is going to be the entity, which is task in our case. And the second is the data type of the primary key, which is long. Here it is. This is the data type that goes here, the second type parameter. All right. And we'll also write a service to show the transactional semantics. We'll also write a service. We will name it task service. And this will have the annotation @service. And this service will use the repository, so we can auto add that repository here like this. And this service will have a method. We can say it save task, task repository dot save. It requires an entity, which is going to be new task, and we can create the entity here, new task t dot set title. All right. We don't need to set the ID because that is auto-generated and will be handled by Spring Data JPA framework. So we have the required service, and to run the application, we'll go to the main class here. And because this is going to be a command line application, we'll use the application runner. We don't have any endpoint expose that we can call. So we'll define an application runner bean. We already know this, how to do that. And here we will inject the task service. Okay. And when we have the instance of task service, what we want to do, we want to call it save task method by passing the title to do. So here's what is going to happen when we run the application. Spring Framework will see that we have defined an application runner bean. So once the application comes up, it will create a new bean, new instance of application runner. It will also inject the task service and it will execute this code, task service.save task. And when we call this method, it will create a new task, and using the repository, it will save the task in the database. All right. So let's run the application, and at this stage, we should see the data in the database table, in the tasks table. So let's run the application first. So we can see it inserted a record because we can see the insert table, and this is because we have enabled this property show SQL true. So let's go to the database and check the task table. So here, if I refresh the database, we should see a table task, this one. And if we select the data, we see a single record with ID 1 and title to do. So that we already know how to insert the data or how to work with a JPA entity. The thing is, how do we enable the transaction? Because if we go to the pom.xml, we haven't added any new dependency. This is the plain Spring Data JPA dependency. This is the connector, and this is just to generate the getters and setters lombok. So the thing is, it is already automatically handled by the Spring framework. We don't need an explicit dependency just for the transactions. The only thing we require is where we want to enable the transaction or the piece of code that we want to run within the boundary of a transaction, we need to use the annotation transactional there. So the good thing about transactional annotation is we can write the annotation on the class level. Notice this is coming from Spring Framework. So we can mark a class as transactional. We can even mark an interface transactional. So what will happen when we put the annotation on the class level or on the interface level, the behavior of that transactional definition will be propagated to all the methods which exist in the class or defined in the interface. So let's say in this case, we are using the class level transactional annotation. So whatever we define here, the transactional behavior will be propagated to this method and all the other methods which we will define in the same class. We can also move the annotation to method level. So in this case, only this method is transactional in this service. Let's say if we have another method here like this method is not transactional. So that is the benefit of using the method level or the class level transactional annotation. So we can do all of this. Even in case of the class level annotation, let's say we have some property, we will cover these properties, but for the demo, let's see. Let's say we have defined the required propagation on the class level. Even in that case, we can override the behavior on the method level itself. So let's say we need to change the propagation. What we can do, we can annotate the method using transactional annotation, and then we can override it to be, let's say, requires new. So even if we are using the class level or interface level annotation, we can always override the behavior by putting the transactional annotation on the methods directly. So in this demo, I'm going to use simple method level annotation, but logic remains the same. So how do we use the transaction? We need to use the transactional annotation on the method or on the class. So just by putting the transactional annotation on the method, this method will now run in the boundary of a transaction. Spring will work with Hibernate and they will create a transaction, a logical transaction on the application side to execute this code within the boundary of a transaction. So let's run the application again and see if we can see a difference. Here we don't see any difference in the logs, but we know this method is now executed within the transactional boundary, but we don't see anything in the logs. How do we know that the transactions are active? So just for the demo and just to enable or check on the local system, we can actually define a property that can show us the status of different transactions when the application is executed. So let's add that property here, and that is going to be logging level And there is one package that we need to enable by setting the log level to debug, that is org.springframework.orm.jpa.jpa transaction manager. Once we enable the log setting for this particular class JPA transaction manager, we can see the transaction status in the logs. So let's rerun the application. And this time we can see that before executing the save task method, it is creating a new transaction. See here, it is creating a new transaction for this method, which is basically the save task of the service method. Then it opened the new transaction, it is exposing the transaction. Then this code was executed because we are calling the task repository save method. All right. And then we see log messages like initiating the transaction commit, committing the JPA transaction, and later we see the insert query from the Hibernate. And once the execution is complete, it will close the entity manager and entity manager factory. But by enabling the debug property of that package, we can now see what is going on with the transaction in this application. And here we can see how the transaction is created and how it is committed. So now we can see this save task method is actually executing within the boundary of a transaction. All right. With this visibility, we can now move on to cover different propagation settings. And with this setting, we will be able to see when a new transaction is, let's say, suspended, or a new transaction is created or propagated. So let's move on. So if we check the propagation attribute of this annotation, there are several possible values as we already covered. For example, mandatory, nested, never required, not supported, requires new, and supports. So we covered that required is the default property. That means when we don't put anything here, by default required propagation will be applied. And what that means is when we use the default setting and run the application, Spring will see if there is a transaction already in progress. If not, it will create a new transaction. So that's what happened in this case. When we ran the application, there was no transaction when this method was executed. And as we saw in the logs, a new transaction was created. So that is the default setting. Now, in order to test or see other propagation settings, we need to have a kind of method chaining where one method is calling another method. And both the methods are using transactional annotation. And that's when we will be able to see how the propagation settings are applied. So how do we do that? We will keep it empty because we want it to be default setting. Now, if we define a method here, as we did earlier, and call that method from this method, in that case, the transaction will not be applied to the method call. So what I'm trying to say is, let's say we have a method here in the same service class, and then we call the method m1 from the save task method, and let's say this method m1 is using the annotation with a different propagation setting, which is, for example, not supported. Now if we call the application now, we may expect that this code will run within the boundary of a transaction, and when we call m1, it will behave based on the propagation setting that we have defined here. But that's not the case. In this case, the transaction settings will not be applied on method m1, because when we call one method from another method within the same class, the transaction behavior will only be applied on the first method, which was called, in this case, save task. And the reason is because the transactions in Spring are proxy based. So these calls are not intercepted. Method to method calls within the same class are not intercepted. So what we will do to test the other propagation settings, we will define another class and we'll write the methods in that class. Then those methods will be called from this service class just to create the method chaining. So let's do that. In this service package, we will create a new class and we can call it service helper. And this is also going to be a service class. And then we can define other methods here. So let's say there is some method called m1, like this. Okay. And we don't need to do anything special here. We can simply print some messages in these methods so that we can test the transaction behavior. Calling M1, and we know the default setting is required. So let's see what else we can do. Next, we can see requires new. What requires new does, if there is an existing transaction under which this method was called, it will first suspend the existing transaction, then it will create a new transaction for this method. So what will happen if we call M1 from save task method? Let's auto wire the service as well. So what will happen when we call the M1 method from the save task method, because save task is already running in a transaction, and when M1 is called, what Spring will do based on this propagation setting, it will suspend this transaction and it will create a new transaction for M1 method. M1 completes the execution and its transaction will be committed. The control will go back to the save task. Now save task's transaction will be resumed. Save task will complete its own execution and then its transaction will be committed. So that's how this requires new propagation setting works. So let's run the application and we know we will be able to see everything in the logs. So here you can see first it will create a new transaction for the save task method. Here it is. And we can also see the propagation setting, which is propagation required. This is the default one. Now this is the first method call when we run the application. So first transaction will be created for save task method. And here we see the repository code was executed. And just before calling the M1 method, it is suspending the current transaction. It is suspending the current transaction because when M1 is called, Spring knows there is a transaction already in progress. And here the setting is requires new. So it will suspend the current transaction. Then it will open a new transaction for M1 method. And then the code of M1 will be executed, which is just the print message in this case here calling M1. And once M1 completes the execution, its transaction will be committed. Then the original transaction for save task method will be resumed. Save task will also complete its execution. And then finally the transaction will be committed by closing the required entity manager and entity manager factory. So here we can see the how the transaction is being suspended and resumed and committed in case of requires new propagation. But let's say from the main class, which is this one, if we directly call method M1, in that case, there will be no transaction which is active. So Spring will create a new transaction. Let's test that as well. So from the task service, we can comment this code. Instead of calling M1 from save task, we will call M1 directly here. So we can comment this one. And we'll also have to inject service helper like this. Let's quickly run the code. And here we can see, because we are calling the M1 method directly and there is no transaction which is currently active. So Spring will simply create a new transaction for this method. All right. That's the definition of requires new propagation setting. Okay, moving on. Let's check other propagation setting. So we'll have, or maybe we can use the same one. Instead of requires new, now we can check the mandatory. All right. So first I will run the application, then we'll see the behavior of mandatory. So let's run the application now. What we are currently doing is we have a method in the service helper and we simply change the propagation setting to mandatory, and here we are calling the M1 method directly. And we see an exception. And the exception says that no existing transaction found for transaction marked with propagation mandatory. What that means is when we use the propagation setting mandatory, it means the transaction must exist. And here, because we are calling the method M1 directly, there is no transaction. And hence, it will throw an exception. It will not create a new transaction. A transaction must exist. Now, if we flip the configuration, that means instead of calling M1 directly, what if we call M1 from the save task method? Because in this case, this is using the default setting. So for save task method, a new transaction will always be created. And if we call M1 from save task method, that means a transaction must exist. It will exist for the save task method. So it should work. Let's check the scenario. And this time it worked because Spring will create a new transaction for save task method, and when it executes M1, here it is, it will participate in the existing transaction. That is the behavior of mandatory. If we are using mandatory propagation setting, then there must be an existing transaction to continue. Otherwise, it will throw an exception that we just saw. Okay, so that is mandatory propagation. Let's move on to a different one. So we have covered required, requires new, and mandatory. Similarly, we have supports. What supports does, if there is an existing transaction, it will join the existing transaction, same as mandatory. But if there is no transaction, then the method will be called without any transactions. That means the method will be executed in a non-transactional manner. Earlier, in case of mandatory propagation setting, if there was no transaction, it was throwing an exception. But in case of supports, it supports the existing transaction, but if there is no transaction, it will simply continue without any transactions. So let's read on the application, because here we are calling the same method from the service. So in this case, it should join the existing transaction, because Spring will create a new transaction for save task. Here it is. For the M1 method, we can see that it participated in the existing transaction. But if we call this method directly, so we can have an additional call with a separator. So if we call the method directly, here for this method call, there is no transaction. There will be no active transaction. So let's see what happens then. And if we just focus on the part which is after the separator where we are calling the method directly, here it will not find an active transaction, so it will execute the code in a non-transactional manner. While when we call the method from the save task method, for that piece, we will see the method M1 will be executed using the same transaction. Here it is participating in existing transaction, but when we call the method directly, in the absence of a transaction, the code will be executed in non-transactional manner without any transaction. So that is supports propagation setting. So we have covered mandatory, requires new, supports, required. Let's cover this one, not supported. So at this stage, we are calling this M1 method from the save task, which is running in a transaction from here, and also from the main class directly. So let's run the application and see how it behaves. Then we will cover the explanation. So here we can see when the method M1 after the separator, when the method M1 was called directly from the main class, it doesn't need any transaction. It does not create a new transaction. That is the role of not supported propagation setting. But what about when it is called from the save task method? So for that, if we check the logs, here you can see just before calling the M1, which now using propagation not supported, it is suspending the transaction. That means when we use the not supported propagation setting, what it does, if it finds an existing transaction which is running, it will suspend the transaction, execute the method non-transactionally, and then that transaction will be resumed. Here it is. But if we call the method directly, in case there is no transaction, even in that case, it will simply execute the code non-transactionally. It doesn't need a transaction at all. So that is not supported. And the last one we will cover in this demo is never. What that means is it will always execute the method code non-transactionally, but if it finds an existing transaction which is in progress, it will throw an exception. So let's check this one. And for this one, I will make a code change here. We will change the order because we know the code will throw an exception. So we won't see the difference. Here, first we will call the method directly, and then we will call the method from the save task method. So here, let's check the first method call, which is calling the method directly. So here we can see we have calling m1 and we don't see any transaction. That is never. Never will execute the code non-transactionally without any transaction. And after the separator, when this code executes, when m1 is called from the save task, we know Spring will create a new transaction for save task method. But when it calls m1, when it executes this particular line, it throws an exception because we are using propagation setting never. So if it finds an existing transaction, never propagation setting will always throw an exception. And you can see the error message here. All right. So these are the main propagation settings that we should be aware of, that we will probably see in many different applications. And we have covered the behavior of these propagation settings. The last thing that we will see is basically the rollback mechanism of the transaction, because that is an important part. So we can close the service helper now, and we can also remove this method call. We can simply focus on the save task method. So when we call the save task method, we will create a new task because we want to show the rollback mechanism. And if we check the status right now in the table, we don't have anything in the table. That's good. So we can actually revert that because of the, this is because of the DDL auto setting. All right. So here, if you notice, we are trying to create a new task. When we call the save task method, it will use the task repository.save method. And when this line executes, it will actually insert a new record in the database. It should insert a new record in the database. But here, as we know, this method is running in a transaction, and at the last line, we are calling method m1 of the service helper. And this service helper method is using propagation setting never. And we know in this case, it will throw an exception. So what happens when one of the statements, one of the operations in a transaction fails? We know the transaction will be rolled back. So we can rerun the application as we did for the propagation setting never demo. So we can rerun the application and we can actually see the rollback configuration or rollback behavior of the code. And we know it will throw the exception, but let's check the logs. Let's check the behavior for the rollback. So here we see, we know it will create a new transaction for the save task method, and it will also join basically the repository code. This code will join the existing transaction to insert the record in the database. But then when we call the m1 method, it throws an exception. And in case of an exception, here we can see it is rolling back the transaction. It is initiating the transaction rollback. And the reason is because all these statements are part of a single transaction, and this particular statement execution is failing. It is throwing an exception. So what Spring will do, it will simply roll back the whole transaction. And that's why even though we call the repository.save method, we don't see any record in the database because the transaction was rolled back. All right. By default, any runtime exception triggers the rollback process, and we can we can control the rollback mechanism. There are attributes like noRollbackFor. That means we can here define the exception classes for which we don't want to trigger the rollback. All right. And then there is setting for rollback for. Here we can define the exceptions for which we want to always trigger the rollback. All right. So the required settings are no rollback for, this one, then rollback for. We need to remember any runtime exception will always trigger the rollback by default, which is happening here because M1 is using the never setting, which will throw the exception, which is a runtime exception, and that's why the transaction was rolled back. There is one last setting that we can cover, which is the read only true and false. What that means is, let's say we have a method which we know will not mutate any data. That method is read only. In that case, we can explicitly mark this property to be true. What that means is it will actually allow Spring Framework to apply some optimizations on the transaction code because it knows this is going to be a read-only operation. So that's pretty much it on the transactional annotation. We have covered almost everything related to transaction, mainly the propagation settings, read-only attribute, and how can we control the rollback settings using rollback for and no rollback for. So that's all for now. See you in the next video. Thanks for watching.